Right, use the diagram below to answer the questions. Is MP tangent to the circle? Well, if line MP is tangent to the circle, we know that this angle right here needs to be 90 degrees, right? And we have a triangle here, NMP, and we know the sum of the angles in a triangle is 180, so we want to see if this angle, in fact, is 90. So I'm going to see if 58 plus 90 plus 33 equals 180. If it does, it's tangent. If it doesn't, it's not tangent, right? So I'm going to add all those up, and when I do, I get 181. So 181 obviously is not 180, so no, line MP is not tangent. Great. If LK is tangent to the circle, what is KN? So here, right, LK, we know is tangent, so now we know this is 90. We want to find KN. So if this is 9 from here to here, this is also 9, right? Those are both radii. So I can set up Pythagorean theorem to find Kn. And this whole length here is going to be x minus 1 plus 9, so x plus 8, right? So I can say x plus 5 squared plus 9 squared equals x plus 8 squared. I'm going to multiply this out, and I'm going to write this as 2 binomials to help me. And it's going to be a lot of foiling involved with this problem, right? Because we have a binomial on each side. So I'd FOIL here, get x squared plus 5x, FOIL here, 5x plus 25 plus 81, FOIL on the other side, x squared plus 8x plus 8x plus 64, okay? We get x squared plus 10x plus 106 equals x squared plus 16x plus 64, okay? Okay, so now we want to get just x by itself. I notice we have x squared on both sides, so if I subtract x squareds go away, and I have just 10x plus 106 equals 16x plus 64, right? Could subtract 10x from both sides, I get 106 equals 6x plus 64. Subtract 64 from both sides, and you get 42 equals 6x, so x equals 7. So pretty involved problem. We're not finished yet. Remember, it says what is Kn? So Kn we decided was x plus 8. So Kn is going to be 7 plus 8, so 15. Okay, so a lot kind of going on there. All right, then another theorem. If two segments with a common endpoint exterior to a circle are tangent to the circle, then the segments are congruent. So here, I notice we have two 90-degree angles here where the line meets the radii. So that tells me these lines are tangent. So therefore, these segments are congruent. So AB is congruent to AC, right? So let's use that now to answer this next question. What is the perimeter of ABCD? Well, I know that if two segments with a common endpoint exterior to a circle are tangent, then those things are congruent. So I know here, I know these are equal. I know, change up the colors, we know these are equal. We know these are equal. And we know these segments are equal, right? So with that in mind, we can fill in some things. So if this is 7, I know this section here is 7. This is 6. we have 6. Here we have 3 and 2, right? So what is the perimeter? We'd add up all these things. So the perimeter of this quadrilateral is going to be 2 times 7 plus 2 times 2 plus 2 times 3 plus 2 times 6, since there's 2 of each of those sections. If I calculate all that, I get that the perimeter is 36 units, right? All right, last question here. Another one that's kind of involved. A satellite requires a line of sight for communication between the ground stations farthest from the satellite. What is the amount of time needed for a signal to go from one station to the satellite and then to the other station? So it's going like this, right? So we want to find this distance so we can calculate the amount of time it takes to go there, okay? So here at this station, it's only going to hit the Earth at this single point, right? And then we have the radius that comes up like this. So we know this angle here is 90 degrees. So the line where the radio waves go from the tower to the satellite, that's a line of tangency, right? So we have this right triangle, which I'm going to draw out over here. We know the Earth's radius is 6,371, so I'm going to fill that in, okay? We don't know the distance from the station to the satellite, but we can calculate this distance right here from the satellite to the center of the Earth. Well, we know this distance, add in some colors, we know this distance right here is 35,786. And we know the Earth's radius is 6,371, right? So to calculate this hypotenuse, I'm going to do 35,786 plus 6,371, okay? When I add those together, I get 42,157 kilometers there, right? So we want to calculate this distance. So we can use Pythagorean theorem, x squared plus 6,371 squared equals 42,157 squared. Okay, we're going to be dealing with some big numbers. Square all these. Square this. I get 405,8964 equals 1,777,212,649. So 1,777,000,000 and so forth, right? Okay, we'd subtract that 4 million plus on both sides, and I'd have x squared equals 4 nope. I'd have x squared equals 17366,23008. I'd want to square root both sides here to get 41672. So 41,672.81 kilometers is the distance from the station to the satellite, right? But remember, we weren't just finding that, although that was pretty involved to get there. We want to get the distance from the station to the satellite back to the other station, so we can calculate the speed of those radio waves. So just getting that total distance is pretty easy. To get that total distance, since we know those distances are equal, since those lines are both tangent, I can just multiply this by 2, right? If I multiply that by 2, I get 83,345.6 0.62 kilometers. We want to get the speed. Now, we're told that the speed of radio waves is 300,000 kilometers per second. So we're given our total distance. To get our speed, I'm going to do 83,345.62 kilometers. And I'm going to multiply that by 1 over 300,000, or just divide it by 300,000 kilometers a second, right? Which cancels out the kilometers part of this. So we have just 0.278 seconds. Great. Again, email me with any questions you guys have. Hope you are well.